Okay, so hello everyone, and thank you for being here. Today, we'll dive together in the wonderful world of render objects. Let me start by presenting you two questions I asked on Twitter, or should I say X now, about render objects. In the first one, I wanted to know what was the percentage of people who have never written their own render object. And as you can see, there is around 70% of people who never did. Who among you never did? You all wrote a render object. Oh, no, you never did. You never have? Okay, only one. Oh, great. As you can see, you're not alone. So who did? Everyone else? No, one. Okay. Okay, two. And the other people, you know nothing about render objects? Okay. So I will try to give the gist of it. And in the second poll, I asked a developer who had never written their own render object, why? A lot of people ever never needed to or don't know how. So if it's the case for you also, it's completely normal. We can also see that there is around 12% of people who are scary of them, and I can understand why. In this talk, I will show you some examples where we needed to create our own render objects in my company. And I hope that you will see how they can make your life easier sometimes. And for those who are afraid of them, I will try to not make you more afraid. So that's me. I'm Romain Rastel. I'm currently working at Daylin, where I'm the Flutter lead developer. My love story with Flutter started in the end of 2017. So it's nearly 6 years now. Please don't tell me I'm old. Back then, I wrote some packages to understand how Flutter worked, and I wrote some Medium articles about what I did. The first package I created was a kind of custom render object. It is called Flutter Staggered Grid View, and I have written a lot more since then. I learned how to tame them, how to make them my best Flutter friends for life. And now, when I see a complex layout, I evaluate if it would be better to tackle it with a custom render object or not. So Daylin, this is a company where I'm working at. We are creating a new payment system aiming to improve the relationship between local businesses and end users. We have created our own backing and chat system, because we are a bunch of crazy people. Our app is fairly complex. We have a lot of non-trivial screens we have implemented. And we are currently deployed in 3 locations in France. And we want to be available in the whole France next year. Before diving into our subject, let's take a step back and look at the following slides you may have already seen. So at the left, you have what you use in your everyday life. Or I hope so, the widgets. The widgets are the blueprints of your views. They describe what you want to do. They are the main part of the declarative paradigm in Flutter. They are immutable, so if you want to change a property value, you have to create a new instance of that widget with that new value. On the right, you have by strength the render objects. They describe how you want to render things on the screen. They are mutable, so they live much longer than the widgets. In fact, every time a new widget instance is created, Flutter will call a method to update that render object with the new values from the widget. At the middle, you have the elements. They are the glue between the widgets and the render objects. They are also mutable. And they are behind every build context you have ever seen. And in case of stateful and stateless widgets, the state instances are attached to the element. There are a lot of widgets out there, either in the Flutter SDK itself or in packages provided by the community through pub.dev and GitHub. Most cases are already implemented. So if you never have the need to create your own render object, this is a question you may wonder. And in my opinion, there are at least 3 reasons why it's suitable to do so. The first one is because it's impossible otherwise with the tool we have. If you need to implement a specific design with complex display rules. For example, let's look at this component. So it's a part of a child view. We can find a lot of apps out there. And let's focus specifically in this kind of stack here, where we have the content of the message, and above it, we have a reaction bar. In our app, the designers always wanted the reaction bar to be at the far right of the content, except in one case, except when the content of the message of another participant was smaller than the reaction bar. At the left, at the bottom left, we have an example of that. And for this specific case, we wanted to add a small space at the left of the reaction bar. So as you can see, this is pretty specific, and I'm very not sure we can do it without creating a render object. Another good reason to have your hands dirty is performance. Let's look at this example. For this component, we want the left gray bar here to be as tall as the image grid on the right. If you use Flutter, I'm pretty sure most of you had this requirement before and ended up using an interesting height widget before. Am I right? Yeah. This is great, but the issue with interesting height that is relatively expensive. It is directly proportional to the square of the widget's tree depth. So if the image grid is a widget with a lot of widgets under it, it will be bad in terms of performance. And in the render object level, we can layout the children in the order we want. Here, we can layout the things on the right first, so that we can get the size, and then constrain the things on the left with that. And this performance is the most performance we can get. And to finish, you may want to go at the rendering level for simplicity. Yes, I know it can be confusing because render objects are not known to be very simple, but everything is relative. In this example, we want to be able to display up to 5 avatars, and depending on the numbers of children, the size and positions of each avatar is different. So maybe we could use a stack or flow widget, don't know, I didn't try it. But for me, it was easier to get at the rendering level to get it done. Because sometimes it's hard to find the right combinations of widgets to get what we want. And it's easier to get it by a render object. As you saw, sometimes the best way to have what we want is to do it ourselves. And for that, we may have to get our hands dirty and create or modify a render object. So today, I will give you some advice to get it done. So let's look at the big picture. You remember this? We have widgets, elements, and render objects. To create a render objects in the Flutter world, we have to comply with this architecture. Fortunately, the Flutter SDK comes with built-in classes to help us. And we'll see together what to choose according to our needs. To create a widget associated with the render object, we have to extend from a render object widget. We have 4 built-in types in Flutter for that. Then we need to create the render object itself. And for that, we have to extend from, well, render object. We have 2 types in Flutter that extend from render object we can use directly. And to glue it all together, we need the elements. But Flutter already took care of them for us, so let's forget about it. Before diving into specific, let's look at the key principles and how immutability meets mutability. On the left, you have an example widget, which is associated to the render object you can find on the right. In the widget world, instead of extending from a stateless widget or a stateful widget, we will extend from something called a render object widget. On both sides, we find the same properties. height, and background color. But in the widget world, these properties are final, since the widget is immutable. And we have a backing field, a getter, and a setter in the render object, so then we can mutate them. There are only two methods we have to implement from the widget side. The create render object, which is a method called by the framework. When you see a new widget at a position, this method is used to instantiate the render object that will live much longer than the widget. And we have the update render object method, also called by the framework, when it detects a new instance of the same widget, same class of widget. And in that case, the Flutter will call that method with the same render object instance, but with the new values held by the new widget. What I love here is the granularity of what to do when a property changes. For example, when the height changes, and only when it changes, because when they are equals, we return directly, then we will tell Flutter that our layout is dirty. We need to recompute it. And to tell it, we will call Mac needs layout, so that Flutter will know that it needs to call the perform layout method after to recompute the layout. And the difference is for background color. If we change background color, we don't change anything about the layout. The height will be the same. So in an effort of optimization, we tell Flutter that we only need to repaint it. We don't need to relayout everything. And this is really great. And this is only something we care about in the render object part. As you can see, on the widget level, we don't care about these things. We only want to tell what we want. For example, if we want a blue sky, even in London, we can have a property named sky and affect the property blue. And it's the job to the render object to make it happen. So let's dive in the widget side of this. We saw earlier that we need to extend from a render object widget. There are 4 built-in types for that in Flutter. And to choose the right one, we have to focus on the number of children our widget will have. If our widget does not need any child, if its layout depends only on non-widget parameters, then we need to extend from live, render object widget. As an example, we have the chat message where we want to put the timestamp on the last text line, if possible. If we don't have any space, we will put it under it. Craig Labens published a great video on YouTube about render objects when it focuses on this example. So if you have never watched it, I advise you to scan the QR code here and watch it after this talk. I will let you scan it. So after that, if your widget will have only one child, then we need to extend from single child render object widget. In our example from previously here, we can consider the widget on the right as only one widget, and the left gray bar here is not widget. We only paint it in the render object. So we can use a single child render object for that. Okay, now you may wonder if my calculations are correct. I talked about 4 built-in types. We saw that it's depending on the number of children. We saw that there are the case for 0 children, 1 child. So you may think that the only one use case left is multiple children. And you are right. But in this case, there are 2 kinds of widgets with multiple children. The first one is when all the children have the same meaning. For example, in the row widget, all children have the same meaning. The logic to position a child will only be dependent on his position on the list. the second one will be layout after the first one, and so on. As another example, we have our avatar group here. Each child represents an avatar. And when we are in this case, we need to extend from multi-child RenderObject widget. The second kind of of a widget with multiple children is when the children have a different meaning. As an example, and even if it's not built like that in Flutter, we can mention the scaffold widget. In the scaffold widget, we have a navbar, we have a body widget, we have a bottom navigation bar, and so on. We always want the body to be below the app bar. So we need to be very specific about that. We cannot randomly insert a navbar in a list and magically let the scaffold guess which widget will go where. We have to be very specific about that. And for that, we need to extend from, let me take my breath, 13 multi-child RenderObject widget. So in our code, we have written the message stack here with that RenderObject widget. Yeah. So now that we talked about the widget part, let's dive in the dark side, the RenderObject one. As we saw earlier, there are two built-in types in Flutter to help us doing so. The first one is in case you want to lazily render children, or if you want to interact with a scrolling system, then render sliver is your friend. I won't go into the details because slivers are very complex and is an entire talk to talk about them. So let's do it. There were another talk in FlutterCon about them. So and is it online? So you can watch it if you want. And if you don't need a render sliver, and believe me, most of the time you don't, then you will need to extend from a render box. Okay, so before diving into some code, let's talk about some key points in the RenderObject protocol. For the layout is a part where we compute the size of the render object and we position its children. In the render object, we have one method for that. It is performLayout. We saw it earlier. The performLayout uses the constraints imposed by its parent to compute its geometry. And depending on the render object type, constraints and geometry are different. In the render box, we use the box constraints to compute the size, whereas in the render sliver, we create a sliver geometry from a sliver constraints. The performLayout has no parameters and returns void. The constraints and the geometry are properties of the render object, and Flutter expects us to set the geometry before returning from the method. So this is a little strange to me because they could create an API, a different API for both of them, where we have the constraints as a parameter of the method, and we return the geometry, but they didn't do like that. Don't know why, but okay, we have to comply with this. After the layout phase, we have the painting one. And to paint our render objects, we have to use the paint method. And in that paint method, you have to be careful about the order in which you paint your children, because every child is painted after the previous one. So if you have some children which can overlap, for example, you paint the widget A and then the widget B, and if they overlap, the widget B will be above the widget I. And maybe this is not what we want. Maybe you want the opposite. So if you want the opposite, you need to paint the widget B before and then the widget A, so that the widget A will be above the widget B. And if you want something, if you want to paint something else, like the gray bar, the vertical gray bar in my widget before, you can do it in the paint method, and you can do it like in the custom paint widget. You have a canvas where you can use it to paint everything. So it's pretty easy. If you have ever used a custom paint, you know what to do in the paint method to paint what you want. Heat testing is about interacting with your widget. If you want to be able to touch or to respond to gestures, you need to take care of heat test self and heat test children methods. Most of the time, you just have to use an algorithm already present in the framework in a helper class. But it can be easily forgotten if you don't override these methods. Your widget won't be interactable. So be careful about that. And let's talk a little about parent data. When you create a render object with multiple children, you may want to store some data between the layout phases and the paint phase. To do that, every render object has a property called parent data, where the parent can store what you want. For example, you may want to store the position of the children you will compute in the perform layout, so that you will be able to get them in the paint phase and paint the children at the correct position. Most of the time, any render object has its own parent data class, which extends from an existing one. And to attach an instance of your parent data class, you need to do it in the setup parent data method. Okay, so I know it's a lot of information, but I think I gave you the basics to start creating your own render object. There is a lot more to know about them, but in most cases, you won't have to dig deeper. So I created a little cheat sheet, I hope to pronounce it well, to sum up what I talked about. So on the left, you have the number of children your widget will have. On the middle, the render object to use. And on the right, you have some helper classes provided by the Flutter SDK to help you doing some things a little quicker. For example, if you are creating a single child render object widget and you only want to override the paint method and let the perform layout and the testing, etc., to be the default, you can extend from render proxy box and only override the paint method, and everything else will be the default. So you don't have to override everything. I don't know if I have a lot of time, but I will try to live coding a render object. Okay, in less than 15 minutes then. So, okay, what I want to do is that kind of object here, widget here, when we have a content and above it we have a badge. The badge, I want it to be positioned at the 2/3 of the content, always, and I also don't want it to be part of the layout. I only want it to be painted, so that the space between two widgets will always be the same, even if the badge gets bigger, as you can see. So here, where is my widget? Okay, I call it content with badge, and we have two properties which are also widgets. So as we saw earlier, we need to use a render object which will handle multiple children. So who among you thinks we need to extend from multi-child render object widget? Okay, nobody. So who thinks we need to extend from slotted multi-child render object widget? One person. Okay, that's the correct response. Yeah. So I will try to create it here, and I have some snippets to help me doing it faster. Okay, I hope you can see something. Okay, so here I will call it content with badge. So here we are extending from slotted multi-child render object widget because the two widgets are have different meaning. One is the content, and the other one is the page. For that, we have to specify something called a slot. It will be, most of the time, it will only be an enum. So here it's also an enum. And then we have to tell it what type of render object we will use. It's a render box here. The first method we have to update, to override here, is child for slot. So when Flutter will call this method with a slot, so ever content and badge, we need to return it the right widget. So here first, we need to create our widget. So final widget content, and maybe, no copilot, sorry. Widget page, because I don't have the network, but that's not required. This content, and then this page, okay, page. So here, I want to return, in the case of the content with page slot, if it's that, I want to return the content widget, and if it's the page, I want to return then the page widget. Okay. Here, the slots here is for Flutter to get all the possible values we can have. So since it's an enum, we just have to return the values here. Since we don't have anything else than widgets, we just have to create the instance without other parameters, because all the widgets parameters are handled by Flutter itself. And we don't override the update render object for the same reason, because Flutter will update the widget properties itself. And then we have to create our render object. So I will save it, and I will change in my main method here. I get the content with page. Okay. Page. Okay. And okay, there is an error, but this is expected, because here Flutter tells us that the render box did not set its size during layout. This is what I told you before. In the perform layout, we need to set the geometry. So here, in the perform layout, I didn't do anything, and I need at least to set the size. So here, I will only get the smallest, just to show you that Flutter will be happy after that. So we'll have a bunch of exceptions, but that's not an issue. And then, okay, nothing is painted, but it's normal, but Flutter is okay with that. That's my code, that's my code. So the first thing I want to do is to fetch the content widget. So I will get it content child for slot, and which is the slot. The content slot is content with page slot.content. Okay, now content. Okay, and if it's null, if content, I want to return. First thing I will do is constraints, not smallest. Okay, and returns return to. Okay, so here we know that the content cannot be null because it is required and it cannot be null, but from the render object side of this, it doesn't know that. So we have to take care of it. Then we have to layout our content if it's not null. So we can layout it. We pass the constraints, and we will use the size of the content to set the size of our widget. So we need to set parent utility size to true, so that Flutter will recall the perform layout method if he detects that the size of the content changes. And then we will set content size. So if I save, nothing happens. Why? Oh, okay. I did not override the paint method. So let's create a paint method here. So I will explain what we do here. So what we do, we iterate through all the children, so the content and the page. Then we will get the parent data I talked about before, where we store the position of the children, and we position each child with the offset property stored in the parent data class. And if I do it, we will have our widgets without the page because we did nothing about it. So let's add it. We will layout the page. We'll get it. Final page. I will copy that. If I know how to copy something, page. Okay, tag, page. And then if page is null, we have nothing else to do, so we can return it properly. And if it's not null, we can position it. And we want to position it at the 2/3 of the size of our widget. So we will get first the parent data of our page parent data, and we'll cast it as a box parent data here. And then we will parent data offset, and we compute the so the x will be the size dot width of our widgets multiplied by 2/3, and the y will be 0 because we want it at the top of our widget. So if I do this and if I 0 okay here, we should be okay. Okay, what did I do? What did I do? Position it. Okay, I must have done something wrong, but I don't see it right now. I get page, okay, batch, So I must have done something wrong. Sorry. Say that with why? Okay. I've done something wrong. I will copy the code before, but I think I forgot to layout it. That's it. Okay, so we layout it, and after the layout, we can paint it. So that's why. Okay, sorry for that. And now we have succeeded to create our own render object to achieve this requirement. So as you can see, this is not so difficult. Everyone can do it. We just have to be careful about some things. Okay, so I hope you see where render object can make your life easier. And I think it's finished. And if you have any questions, I will be pleased to answer them. Thank you.
Thank you for that. It was great, and it was actually my first time taking a look at how that render object and everything works. So I really enjoyed it. I have a question, and maybe this is like way off the point, but like, is there a way to make animations work within render object, or is like animations still generally being taken care outside of that? And yeah.
Okay, it depends. If you want your animations to be bound to some layout constraints, some of Flutter widgets do some animations. I think I might be wrong, but I think the one with when the size, the animation size, or it is scaled, what it is called, animated size widget. I think it is created like that because we have to do the animation when we know the size changed, but most of the time you don't need it.
Okay, thank you.
Okay, thank you very much.